Hi, chemistry students. I wanted to help you through the lab with determining the complete formula of a hydrate. Now, I'm going to walk through one set of data and to help you through the math with the steps, okay? With most of the classes, I explain the molar mass of copper sulfate, molar mass of water, but I'm going to go through those steps together. But I also recorded all the data from each class that we were doing in class at the end of the period. So I wanted to show that with you. Okay, I've got period one. The substitute is going to share this data. She's got a digital version of this, so she's going to post it on the wall, on the view board. But I did get your data collected for all of period one with the 3 great volunteers that did the lab. So this will be posted on the screen here before you, so you guys can pick data. You could pick Vanessa's or Lillian's or Michelle's. Each one of them will come out with great data. I ended up heating them up quite a long time during study, the second period study hall that I have. So, but anyways, Miss Manger, I think I'm saying how to pronounce the last name, but she's going to post this on the wall so you guys can record your numbers on your lab sheet. Okay. I also have period threes data, and then I also have period all the other classes, period fives, period sevens, and eights, and I have period tens as well. But for each class, Miss Manger, she's going to go ahead and post this on the view board as stilled pictures. Okay. So let's go ahead and talk about the data. I'm just going to grab the first set of data. I'm going to use Vanessa's from period one. And she had a bowl of 5335. Now you guys have whatever mass you write down here, whatever mass you have. But we went ahead and had that written down so that we could quickly take away the mass of the bowl when we get the starting hydrate and when we get the dried form. This is your starting hydrate. This is the mass before heating. Okay, and she had 3.29 grams of the copper sulfate hydrate. And then after heating, after a long time of heating and getting all the water removed, we had it down at 2.09. Okay, so when you have your two numbers, whatever two numbers you have, everybody throughout the whole day probably has different numbers than I do. You're going to subtract these two. You're going to subtract these two to get the mass of the water. You're going to subtract the before and the after to get the mass of the water lost. Okay. And then you're going to be only focusing on the 2.009. You're not going to worry about the hydrate mass anymore. After you subtract the numbers to get the mass of water, you're not going to use 3.29, okay? You're going to focus on using the 2.09. So put your mass of the dried form right here, and then put your mass of these two subtracted. I'm going to go ahead and subtract these two, and it's come because you're going to take 3.29 minus 2.09, and it comes out to be 1.20. Okay, and so this is your hydrate, the dry anhydrous form of copper sulfate, and then this is your grams of water. Okay, now we're going to use those in a minute. I did want to describe, filling in the color of the blue compound. The formula is CuSO4. We heated it slowly for 10 minutes. I even went longer through my next class period. But basically what we saw happening is that the hydrate changed color. It basically changed color from blue to an ugly lighter gray. Okay, into a lighter gray color. And then obviously the mass did go down, and you could say yes or no, whichever you think you write down here is fine. Hopefully you're going to say yes, because we've been talking about this concept for a couple of days. And what's happening is that basically the water is being evaporated. It's easily evaporated away from the crystals, from the dry crystals, Okay, that's what's happening. Go ahead and fill those in. Fill those parts in. That is totally fine to do so, okay? Now, to help out with the math, you're going to take the 2 of these. We subtracted to get 1.2. We also have the 2.09, and that's the 2 numbers we're going to use. We're going to use these 2 numbers, okay? So what we're going to use here, let me move the screen closer, is that we're going to go ahead and use the 2.09. But what we have to do next, this is our next step. We did steps 1 and 2 to figure out the 2 masses. And then we're going to take the mass of the dry copper sulfate, 2.09, and we're going to divide that by the molar mass. I ended up already adding that together. It's copper plus sulfur on the periodic table, and then 4 oxygen, 64. We're going to add those together, add these together, and we're going to get 159.6. So we're going to take 2.09 divided by 159.06, and that's going to equal the moles of dry copper sulfate. So again, you're going to take 2.09. Actually, this is where I wanted you to put it here. So go ahead and rewrite it here as well. 159.6, and then that equals 0.0131. So once you get past the zeros, definitely try to use 3 digits. Do that also on your homework problems too. Don't just take the 3. It's going to mess it all up if you only take one non-zero number. You got to go further out when it's really small, okay? Then we're going to focus on the 1.2, and we want to get to moles of water. So we did the moles of the dry compound. Now we're going to do moles of water. We're going to take the 1.29 grams of the water and divide that by the 18, okay? This is going to give you grams to moles of water, and we're going to get this time 0.0666, and it's really good to use as many of the digits past the zeros when it's really small. And these are both moles, and again, you should see the water moles being higher than the dry compound moles, and we're going to put 0.0666 over 0.0133 here. And when you round that together, I think it comes out to be, mine come out to be on the calculator as 5.009, which is really, really close to 5. Okay, and then you're going to go ahead and put in the formula of copper sulfate with 5 waters, and then you're going to name it, and that's going to be copper sulfate, and then say pentahydrate. Okay, now I walked through literally the paper for Vanessa's data. Thank you, Vanessa, for doing that from period 1. But you guys are going to have different numbers. You're going to have different numbers here, a different number here. But you're going to take this number and you're going to divide that by 159, whatever your number is, and that's going to be your moles of copper sulfate. Then you're going to take your subtracted number of your mass of water divided by 18. So your numbers are different, but you definitely want to go further out past the decimal for both of them and take your water moles over your dry compound moles to get your number of your number for your formula, okay? And this is how you would complete this. In order to complete it, make sure you put your name on your paper and you can turn it in if you could do that. Try your numbers out, and if you want to talk to me about it on Monday, that is totally fine, okay? This goes along with the homework problem number 13, and we didn't actually go over it with period 5, 6, 7, 8. So I definitely want to help you with that, and we've got a few minutes here, so I want to help you set this up for those classes. You guys on period 1 and 3, you probably could stop the video if you wanted to, since I've already went over this example, okay? But for periods 5 through 10, I didn't get a chance to do that. We ran out of time with our shortened classes, okay? So I just wanted to show you guys this. It's a very similar problem. I'm going to go ahead and show it all filled out already just to save time on the video here, because we only have about maybe 5 minutes left. But this has the same kind of data with 27 grams to start and then 17.9 grams after. So we're going to use 27 and 17.9, and then you're going to subtract these two, and that's going to be 9.1. Okay, and it's going to be this mass that you're going to use for your conversion step, and then you're going to use this mass to get the conversion step with water. Okay, and you're going to use the 159 like we use 63, 32, and 64. And we basically get it up to 159.5, 159.6, and take the 17.9 divided by 159.5 to get 0.112 moles. And then we use the 9.1 grams. That's the water lost. Okay, you divide it by 18 to get 0.506. And then you're going to divide the two, the water moles divided over the copper sulfate moles, and it's going to be a little bit lower. Your lab data may not be a whole number like it is on this problem. So you're going to round it up to the nearest whole number. And again, it's copper sulfate with 5 waters, okay, with 5 waters. So I just wanted to put this on the screen for period 5, 6, 7, 8, and 10. We didn't get a chance to fill this out. Feel free if you want to stop the video and so people can copy it down. That is totally fine, okay? But I wanted to make sure you guys had this one done since some of the classes got it covered, others did not. Your goal today is to get anything done on this page as much as possible. Try to get anything done on this. Try to get anything done on these problems. And then hopefully on Monday, we'll be able to go over it, talk about it, and we're going to be having a quiz on this on Tuesday. So you're definitely going to be having this count for points and working on it today, working on it Monday. It will count for points. So I'm going to go ahead and stop the video now and to please work on the homework pages 2 through 4 on the homework packet, and then also to complete your lab. That's the goal for the rest of the period, is to work on, sorry about moving this around so much, but you want to work on your lab paper, okay, and follow this example with your numbers, okay? If you have any questions, feel free to reach out on Remind. I can reply back, not a problem, okay? I'll let the substitute know that to tell you, hey, give me a reminder if you have any questions. Send me pictures. If you want to say, hey, is this right? Don't even hesitate to send me a picture, okay? We'll see you later. I'll see you on Monday. Bye-bye.